Hello guys, myself Mahendra and I am from Sri Venkateswara College of Engineering, and today I am going to explain you about what is Diffie-Hillman key exchange algorithm that can be used in cryptography. Let's begin with what is Diffie-Hillman key exchange algorithm. A Diffie-Hillman key exchange, it is one of the method of digital encryption that securely exchanges cryptographic keys between two parties over a public channel without their conservation being transmitted over the internet. The two parties use symmetric cryptography to encrypt and decrypt their messages. The Diffie-Hellman key exchange, it can also known as exponential key exchange algorithm, and it is one of the method for securely exchanging the cryptographic keys over an insecure channel, and it can also be the fundamental building block of many secure communication protocols, including SSL, TLS, and as well as SSH. The Diffie-Hellman key exchange works by allowing two parties. For example, let us consider Alex and Bob. They both of them agree on a shared secret key over an insecure channel without any other party being interrupt the key. Let's see where is this Diffie-Hellman key exchange algorithm it can be used. The Diffie-Hellman key exchange, it can also known as exponential key exchange. It is widely used in trusted techniques for securely exchanging cryptographic keys over an insecure channel, and it can be used in many different contexts. It may include secure communication protocols. The Diffie-Hellman key exchange, it can be used in many secure communication protocols such as SSL, TLS, and SSH to establish a secure channel between two parties. It allows the parties to agree on the shared secret key that can be used to encrypt and decrypt the messages exchanged over the channel. And it can also be used in virtual private network, that is VPNs. The Diffie-Hellman key exchange, it is often used in VPNs to establish a secure connection between a client and as well as server. It allows the client and server to agree on a shared secret key that can be used to encrypt and as well as decrypt the secret exchanged over the VPN connection. This Diffie-Hellman key exchange algorithm, it can be used for the purpose of secure file transfer protocols such as SFTF, SFTP, and FTPS to establish a secure channel for transferring files between two parties. It allows the parties to agree on a shared secret key that can be used to encrypt and as well as decrypt the transferred files. And this algorithm can also be used in the other applications where secure communication is required, such as secure mails, secure web browsing, and secure voice over IP. It is a flexible and widely supported technique for establishing secure communication channels. Overall, Diffie-Hellman key exchange, it is one of the important and widely used technique for securely exchanging cryptographic keys and establishing secure communication channels. It is an essential component of many secure communication protocols and as well as some of the applications. Let's see how does this Diffie-Hellman key exchange algorithm it can be work. Here the key exchange involves the following steps, like let us consider Alice and Bob's. These are the two parties. They agree on two large prime numbers P and G and a public key exchange algorithm. Here Alice chooses a secret integer A and computes A is equal to G power A mod P, and she sends computed value A to an Bob. Here Bob can also choose a secret key integer, that is B, and computes B is equal to G power B mod B, and he sends B to Alice. Here Alice computes secret key, that is S is equal to B power A mod B, and Bob computes a secret key, that is A power B mod B. Here Alice and Bob now both have shared secret keys which can be used to establish a secure communication channel. The security of this Diffie-Hillman key exchange relies on the fact that it is infeasible for the attackers to determine the shared secret keys from the from the public values such as P, G, and A and B. This allows Alice and Bobs to exchange the keys securely even over in an insecure channel. And this is the example for how does this Diffie-Hellman key exchange algorithm it can be worked. In step 1, Alice and Bobs get public numbers, that is P is equal to 23 and G is equal to 9. In step 2, Alice selected a private key A is equal to 4 and Bob selected a private key B is equal to 3. In step 3, Alice and Bob compute public values using a formula known as G power A mod P and as well as G power B mod P. Alice uses G power A mod P and get the public value, that is 6, and Bob uses G power B mod P and get the value, that is 16. Here Alice and Bob exchanges the public numbers. In step 5, Alice receives the public key y is equal to 16 and Bob receives public key x is equal to 6. In step 6, Alice and Bob compute symmetric keys using a formula known as for Alice y power A mod P and she gets 9, and Bob uses the formula x power B mod P and gets symmetric value, that is 9. Now both Alice and Bob, they will be having the same secret key. It can be used to decrypt the messages. Now let's see what are all the vulnerabilities of Diffie-Hellman key exchange algorithm, and these are all the some of the disadvantages of Diffie-Hellman algorithm. The Diffie-Hellman key exchange algorithm, it is a widely used and trusted technique for securely exchanging cryptographic keys over an insecure channel. However, like all cryptographic systems, it is not completely immune to attacks and vulnerabilities. Some of the potential vulnerabilities of Diffie-Hellman key exchange algorithm, it includes man-in-the-middle attack. If an attacker is able to intercept and modify the messages exchanged between Alice and Bob during the key exchange, they may be able to impersonate Alice and Bob and establish a secure channel with the other party. This can be prevented by using the certificate-based authentication and or by verifying the authenticity of the message using the message authentication codes, that is MACs. Max. Next disadvantage is small subgroup attacks. If the prime number P used in this key exchange as a small subgroup, an attacker may be able to use this to their advantages to recover the shared secret key. To prevent this, it is important to use a large prime number with no known small subgroups. Next disadvantage is exponent attacks. If the secret exponents, that is A and B, used in the key exchange are not chosen randomly, the attackers may be able to use this to their advantages to recover the shared secret key. To prevent this, it is important to use the strong random number to generate the secret exponents. And these are all the some of the important disadvantages of Diffie-Hellman key exchange algorithm. Thank you.